Hello everyone and welcome back to the channel. In this video, we are going to simulate Cmos NAND gate using ngSpice. In digital electronics, NAND and NOR gates are two universal logic gates that are used to perform Boolean operation on multiple input variables. These gates produce an output based on the combination of the inputs applied. In Cmos technology, NAND and NOR logic gates are designed by connecting NMOS and PMOS transistors in series and parallel connection. In this video, we are going to see NAND gate using Cmos technology. It consists of two PMOS transistors Q1 and Q2 and two NMOS transistors Q3 and Q4. The PMOS transistors are connected in parallel between the power supply VDD and the output terminal Y. Similarly, the NMOS transistors are connected in series between the output terminal Y and the ground terminal. Now let us understand the operation of the Cmos NAND gate. Let's consider case 1 where both the inputs are low. So when both the inputs are low, PMOS transistor Q1 and Q2 are on and NMOS transistor Q3 and Q4 are off. Hence there is a closed path between the supply voltage VDD and the output Y. Thus the output will be connected to the voltage level VDD. Although there is no path between the output terminal and the ground terminal as both NMOS transistors are off. Under this condition, the output line will maintain the voltage level at VDD, which indicates that output is high. Let's consider the second case wherein one input is high and second input is low. In this case, the PMOS transistors Q1 will be off and Q2 will be on. Similarly, in case of NMOS, Q3 will be on, Q4 will be off. Under the switching condition of the Cmos transistor, the output terminal will be connected to the power supply through this path VDD, Q2 and output terminal. Since both NMOS transistors are connected in series, the NMOS transistor Q4 is off, hence there is no path between the output terminal and the ground terminal. Therefore, the output line will maintain the voltage at VDD and the result of this case will be high. The same thing will happen for the other case when A is low and B is high. In that case, Q1 will be on, Q2 will be off, Q3 will be off, Q4 will be on. So, in that case, your path will be from VDD, Q1 and output. As here Q3 will be off, there won't be any path between ground and the output. So in that case also your output will be high. Coming to the last case wherein both the inputs are high. So in this case, both PMOS transistors Q1 and Q2 are off and both NMOS transistor Q3 and Q4 are on. In this case, there is no path between the output terminal and the supply VDD. But there is a direct path between the output terminal and the ground terminal. As you can see here, this results in the ground voltage level at the output terminal and produces the low output. So your output here will be low. Now let's write the ngSpice code and check the output. So this is the circuit diagram we will be referring. We are having a PMOS connected in parallel and NMOS connected in series. So let's write the code. First line will be the title line. So NAND gate. Now let's define VDD, which is connected between 1 and 0. And let's say the value of that is 3.3 volts. Next we'll define the MOSFET M1, which is connected between drain, gate, source and substrate. Let's give the model name as PFET. Similarly, for the second model M2, drain is connected here at 2, gate is at 5, source substrate it is 1. And model name, let's give the same PFET. Third MOSFET M3 is connected between drain is at 2, gate is at 4, source substrate is at 3. Let's give this model name as NFET. M4 is connected between 3, 5, 0, 0. Let's give the same model name NFET. Next, define the input VA, which is connected between 4, 0. Let's give here pulse, starting voltage, ending voltage 3.3. We are not defining any rise time, fall time, time delay. I have explained this pulse in previous video, you can check it out. Defining the second input B, which is connected between 5 and 0, giving a pulse, starting voltage, end voltage, and the period. Next, define the model. Dot model FET Cmos. Second model is dot model NFET NMOS. Then we are defining a trans analysis. So dot trans 0.1 micro is the step, and it will go from 0 to 100 micro. Then writing a control part. Under that, let's give a set color 0 as white for the background. To run the code, here we require 3 plots, 2 inputs and 1 output. So input is at 4, node 4. Second input is at node 5. As it will overlap, we'll give a spacing of 5 here. Then output is at node 2. Let's give spacing here as 10. And the control part and the netlist. Now let's simulate this code. Let's save this code as nand.sp. Now we'll open the console and run this code. Nand.sp center. You can see here the output. Green one is the input, red is the second input, and blue is the output. That's it for today. If you found this video helpful, then don't forget to like, share and subscribe. Also, if you have any questions or suggestions for future videos, then let me know in the comment section. Thanks for watching.